So as I explained, right? So let's take car. So this is one of the class. I have defined a class called car, but car as such is not going to be a specific object, right? You can't say I bought this model of car. Like you basically say this. I have bought this model of car, but you don't say there is nothing like car as such as a concrete. So basically, whenever you buy a car, it is going to be specific to a brand. It is going to be specific to a model. It is not going to like uh, a car is basically an abstract thing. Car means it is going to have four wheels, it is going to have two lights, it is going to have steering, it is going to have engine. So it is basically a template, right? So we can't basically have something as a car. So it is not a concrete thing. So it is just a template, it is just an imagination, it is just a group of collection of features or properties. That is what we basically we basically call it as car, or whatever may be the vehicle, right? We basically say this is the car, but we don't basically have anything like a car as concrete, right? So that's where I was saying. So whenever we define a class, this is how basically we define a class. We have a keyword called class, and then we basically give what is the name of the class. So we can have it as car, whatever we wanted to have, right? So we can give the name of the class, and then open the flavor basis and just close it. So that's enough to basically declare a class. And all the things which goes inside the flavor braces are going to be the properties or functions which are specific to this particular class. So as I mentioned, right, car is it is just a particular thing which is not going to it is not going to be a concrete thing. So once we give properties to that particular class, right, then only it becomes an concrete thing, which is nothing but an object. Okay, so let's take we have a class called car, which can have which have a functionality called start engine. And there is something that it can accelerate, and we can have something like a top speed. So these are the characteristics or the functions which a car can do. So as I mentioned, right, so a car is going to be a high level object, which where all these features, right, all these features are going to be present in most of the cars. So what we can do is we can inherit this particular class to construct or to start a different type of end class. Like, so let me show. So let's take we have we have a class called Honda. So these we have so many companies which basically build car, and each company will have their own uh, like technologies, right? So they basically go with electric, they basically go with petrol or whatever it may be, right? So all these specifications are going to be with respect to the Honda, but whatever things we have actually defined in the car, right, it is going to be common for every car. So start engine and get top speed or whatever speed, right? So these are common for every car, but few things which are specific to Honda company cars, right? So which define those functionalities in this class Honda. And instead of defining all the functionalities which are there for Honda, right? So what we have done is we have kept common features, whatever common features we have inside this car class, and we reuse them whenever we build different companies car. So let's take Honda, right? We basically take all the features which are present inside the car class. So this is where we get into inheritance. So we are actually reusing whatever functionalities we have inside the car class. So this is how the syntax goes. So we just need to put a colon, and then we need to put a car. So all the functionalities which a car is going to have will be reused in the Honda class. So this is where inheritance comes. So let's take, I have one more model, like one more company called Audi, right? So we so this is Audi, and they have their own technologies to build a car, but definitely all the cars are going to have the same functionalities which we have defined here. So what this is where basically we make the design so clear, right? So we put all the common things in one class, which we call it as base class, and we derive them into different classes like Honda or Audi. So these classes are called derived classes, and apart from whatever common functionalities we have inside this class, we're going to write some specific functionalities for the derived classes. So let's take, they don't want, they want a functionality called stop car, they want some mood disk or something, right? So they want some other functionalities apart from whatever we have in the car. So we can basically write our specific logics here, and it basically, this class is going to have all the features which are present in the car, plus whatever features we are going to define here. So that way we basically give a shape to this particular class. So this again, right? So we have a company, and we have different types of models, right? And so we basically, let's take, a company has decided that the basic speed which a car, Honda car, is going to have is 80. So whenever we basically design different cars, right? So it basically goes with different top speeds. So but the basic speed which the company have defined is 80. So that is going to be a basic speed. So whatever may be the Honda car, right, whatever may be the model, it is going to be like 80. So let's take, we are actually defining a new car model like Brio. Okay, so we have inherited Honda whenever we have written this Brio class. So once we put this colon and this Honda, it basically inherits all the functionalities which are present in this. So it means it is going to basically inherit all the functionalities which are present inside this. But Honda itself is actually inheriting so many features from car. So what it means, Brio, which is like our new model, is going to have all the features which are present in car class, which are present in Honda car, right? So all these things, right? So can be reused in this particular class, because we are actually inheriting this. So this is where we make use of inheritance. Instead of writing all the features in Brio, right, we just defined and then we have just inherited. So we are not doing anything, we don't have, we have not defined any features in this particular class, but still it is going to have all the features which are present in Honda, which are present in a car class. So something like that, we so let's take, we haven't, we want, this car has to follow like the Honda standard, which is like 80 is the top speed. And let's take, we want to design a new car which is going to be like having a top speed of more than 80. So let's take, we are designing some car called City. So and the top speed of that car is not actually maintained as default, it is going to be like something other than 80. So we are given an opportunity to override the functionality which is defined in the base class. So this is where a polymorphism comes. Polymorphism is nothing but we have a functionality, or we have a property already called get top speed in the base class. So let me go to base class. We already have something which is defined. So this is going to be the one which is going to be the defaulted for all the car models unless and until you override it. So we haven't done any logic here to override that, right? So that means it is going to contain the top speed as 80, but we can use polymorphism concept to override that functionality. What it means is we get all the functionalities which are defined in this particular class, but we want a particular functionality. Let's take Honda is having some 10 functionalities or 10 properties as such. Okay, but we want to override or we want to change a particular functionality specific to a particular class or like city. So let's take this one, this the top speed we want to change for city, except top speed I want all the functionalities which are present in the Honda. So at that point of time, what we can do is we can use polymorphism to override that particular functionality and then get our new class, right? So we use polymorphism for that. So the way we actually implement polymorphism is by using a keyword called override. So we have a functionality called get top speed in the base class, and as a derived class I want to override that functionality. For that I'm going to use override. So once I override, the functionality will be overridden, and then the new top speed is going to be 200. So this is where we use polymorphism. This is called dynamic polymorphism, and this basically comes into picture whenever we run the program. So it means at runtime it is going to take into effect, not the compile time. The basic difference between compile time and runtime is whenever we write code, right? So we are writing code. So at the time of writing itself, if we know that this is going to happen, it is called static or like compile time or late binding. We call these names. If at all we don't know what is going to happen, which method is going to happen, what functionality is going to call, right? So while we do coding, if we don't know and it is going to be decided based on some factors, then it is going to be like runtime. We call it as runtime or late binding. Dynamic polymorphism is a few things which we basically use in runtime. And yeah, so this is where we basically use polymorphism. And so when I say abstraction, so let's go to abstraction, right? So when I when I say car, right? So when I define this particular class, so I know that there are so many types of cars which have this common functionality, and which needs to be decided by each of their models, right? Each of their car models. So at that point of time, right, we basically take all the features which is common for all the car models, all the car companies, everything we take into consideration, and we put some template. So that particular thing we try to make that as a high level. I mean, you can't basically imagine, you can't basically get a concrete thing out of that. So something like which this basically helps you whenever you are designing a enterprise level application which is having so many entities, and you want to take particular functionalities into common, right? And then put together in a class. So abstraction is basically just taking the common things and then putting it into a class, which basically helps us to maintain the code and improve the reusability of that particular application. So that is where we use abstraction. And encapsulation, we have, let's take, yeah, so let's take there is a functionality called stop car. Okay, so the customer who is going to use the car is keen on whether the car gets stopped or not. He don't need what is going to happen inside the car, what is going to be the technology used on all these things. So when we design the applications, right, when we design application, or when we uh, uh, make classes, right, so we follow all these rules because it makes developer job very easy. So instead of exposing unnecessary or unimportant things to the customer, right, we actually maintain encapsulation. So let's take, we have a car called Honda, right? So that particular car is going to expose a functionality called stop car, but it is not going to expose what is the flow, or what are the steps it is going to follow to stop the car. Let's take, we have few steps which is going to like move disk or reduce the gas flow or all these things, right? So it is not going to basically uh, put all the steps in front of the customer. It is just going to say that car has stopped or it has not worked on all these things. So just few options it is going to put, but not all the details which customer is like he don't need all these things, right? So yeah, even when we write coding, right, all these things we follow, and this is where we get encapsulation into picture. So when, yeah, so this is the basic program which I have written to showcase the functionality of OOPS. So here I'm just declaring a class which is called program, and I'm just writing a main method which is a starting point of C# program. So wherever you, so this is actually identified by the C# compiler, and whatever functionality you want to have, right, you can write it here, and then you can execute them. So what I am trying to do here is we have a class called city, which basically showcase a car called Honda City, right? So what I'm trying to do here is, so I'm creating an object of the class Honda City. So Honda City is going to be the object name. So this is how we basically declare an object. We give a class, we give an object name, and the new is the keyword which is defined by the .NET framework to identify that we are going to create a new object. So this new keyword is very much necessary because this is what is understood by the compiler, and it is basically used to do the background work. So whenever we create an object, right, it is going to create a memory space for us in the disk, and so whenever we use this new keyword, it tells the compiler that we have created a new object and we have to create the memory for all these things. So I just created an object and then calling the object. So all this object is going to have all the functionalities which are defined in this class, and also which are inherited from the base class. So I'm just trying to call, and then I'm just printing what is coming up from here. So let me run the code once. Yeah, so I'm just creating the class, and then I'm just calling this method get top speed. So the class which is like a city is not having the top speed of 200. It is actually overriding the functionality which is coming up from the class called Honda. So it is the base speed for this particular class is actually only 80. So for all these classes, so but it has been overridden here. So if you see, right, we have used polymorphism to override that functionality. If we go for one of the car model like Brio, we haven't overridden. So let me create um, an object with this particular car model, right? And see what is going to be the top speed. So we haven't overridden any functionality which we have inherited. So let's see if at all it gets the overridden functionality, or it is going to get the base class one which we have defined. Yeah. So you could see that Honda Brio's top speed is only 80. This is because, so as you could see, right, we haven't defined anything for this particular class, right? We haven't defined anything for this class. You could see there is nothing here, but we have got a functionality called top speed, which is basically inherited from another class. So this is where we get the reusability part, right? So we are reusing this functionality, which is not even defined. And so we didn't define that functionality, and we didn't define what is the value of the top speed, anything. So but still we are able to use this functionality. That is where we get the inheritance into picture. But when it comes to Honda, right, we in Honda also we can just leave, like Honda City, right, we can just leave the functionality as such. But the requirement is like, we want to override the functionality which is defined by the base class. So in that point, right, we have overridden that particular functionality which is defined as 80. We have overridden that into 200, right? And we were able to achieve that. So we were able to override this whole functionality, right? So that is where we basically get the polymorphism into picture. And abstraction and encapsulation are basically more of design level perspectives. So it is like well and good to have encapsulation abstraction, because it gives developer a clear picture of what is happening in a very big application. Yeah. So these are the few and like this is one of the example which I just come up to showcase. Oops. And I could see, I could explain this one, right? So yeah, so when I told encapsulation, right, so you have something called stop car. So when we create an object for the Honda City, right? So whenever you want, you have created an object and you want to see what are the properties or what are the functionalities which we have. So we have something called Intellisense, which is used in the Visual Studio. So once you put a dot, right, it gives all the functionalities which a particular object can do. So you could see start engine and then stop car. So both functionalities are there. So start engine is basically is not defined in the Honda City class. It is actually getting inherited from the base class. So you could see you don't have anything like start car here. So it is basically inherited from the base class. So when you see here, right, so in Honda City we have defined some more functionalities like this one, right? So some two more functionalities like mood is can reduce gas flow apart from stop car, but you could see you're not going to see them here. So that is where encapsulation comes into picture, right? So you don't basically expose all the functionalities whichever you have defined. So that is of not like no use of having all those unnecessary functionalities exposed to the customer. So what you have exposed is stop the car functionality, stopping the car, right? So that all that particular functionality you have exposed, and other functionalities which are not exposed, you are actually using it internally, which is not actually required for the customer to know. So that is where encapsulation comes into picture. You don't basically put all the functionalities in front of the customer and confuse the customer, right? So you just put a functionality which makes use of all the internal things to get that functionality done. So that is where we get the encapsulation into picture.